Gentlemen, or good afternoon, depends where you're joining from. This is Belén Gallego from Mata Insights, and I'm joining today from Madrid. Please feel free to use the chat to tell us where you're joining from. We always like to see and welcome everybody. And hello, El Mabrouk, it's good to see you here. So today in this webinar, we look at bifacial PV modules, and we are actually going to study during this webinar itself, what are the actual panels like? How do they work? How do they work in relationship to the two phases? Most of the people here, I am sure, are already familiar with PV, are already very familiar with bifacials, and you're going to learn a great deal about the panels themselves today. Then, as you know, tomorrow we're going on to the plant design itself and how to design the plant for maximum optimization. And with me today, two super experts of these bifacial PV panels. I have with me today Antonio Ruta. Antonio, can you introduce yourself very briefly and tell us where you are joining us from?
Thanks, Belen. I'm Antonio Ruta. I'm the technical manager of Jinko Solar. At the moment, I'm joining this webinar from Sao Paulo, Brazil.
Excellent. Happy trip. I love to be there as well. And Juan Carlos, can you tell us a little bit about yourself and where you're joining from?
Yeah, this is Juan Carlos González from Longi Solar. I am from Spain and now talking from Madrid. I am based in Barcelona and technical department. Thank you for inviting.
Thank you very much, Juan Carlos. We're going to hear then today about bifacial PV panels, as we said, and I'd just like to take a second to actually ask you guys over here. So we've got here people from Chile, from Casablanca, from even Sydney, so somewhere here. We have from Malaysia, from Madrid, calling from Madrid. We've got people from Mexico, from Lisbon, from South Africa, from Italy. So clearly we have people from all over the world, you know. Welcome everyone, keep on sharing with us. Why bifacial? Well, as you know, you guys, the cost of PV has been decreasing on the tenders over time. We're now like a minimum, historical minimums. You know, we've seen the 2 point somethings, we've seen the 1.8 already in South Africa, you know, even the Mexican markets. And this is really a trend that is continuing. So what we need to do is we need to get clever, we need to get our costs down. And the bifacial is one of the main technological trends that most of the module manufacturers are following at the moment, or some of them are following, in terms of keeping reducing these costs. There are big promises to this technology, and let's get to understanding a little bit better. Antonio, I would ask you first if you could share your screen, please, so that we can see your presentation. We'll hear a presentation from Antonio, then from Juan Carlos, and then we'll take questions and answers. Make sure to use the Q&A box at the bottom, and we will take those. And whilst Antonio prepares his screen and everything, just to let you know, we are recording this session, and we will be making available the recordings and also the materials after the webinar. You ready? Make sure you unmute your microphone, please, Antonio. We can't hear you at the moment. We can see the presentation, but we cannot hear you. We just need you to switch on your mic. Perfect.
Okay, should be okay now. Okay, thanks for the invitation. I'm here to present our Jinko Solar bifacial. This is the agenda of today. Some key facts about Jinko Solar. We are present with more than 31 subsidiaries around the world. We are present with more than 80 countries with our representative. We have 80 global factory plus one, that is the one that we are going to do in USA. At the moment, we are the first producer in the world. The capacity of 2017 was 1.5 gigawatts, and the capacity for this year, 2018, is estimated between 11.5 and 12 gigawatts. This is according to the last quarter results. Thanks to the efforts our R&D department, we have diversified our portfolio, and we can say that our portfolio, at the moment is one of the widest in the PV industry, because we have more all from poly to mono PERC, dual glass backsheet, and we can offer more than 230 BOM combination of different technology, model type, and add-on solution. So let's go through the bifacial, some technical concepts. I will try to be as fast and conscious as possible, so that we will come in that data to start to answer to some questions. Particularly the bifacial technology one is the one of the technology that everybody are looking for the simple reason that it will permit to go down with LCOE and to increase the return of investment.
Antonio, let me stop you there. Just one thing. For some reason, your presentation is quite pixelated and we can only hear you okay. Would you mind resharing the presentation? Okay, and then speaking slowly. In the meanwhile, what I'm going to do is I'm going to ask my colleague, whilst you reshare your presentation, make sure to choose your document again. I'm going to ask Araceli, can you throw a poll? Do you know what you have to do, Antonio? Just
okay, we'll
go to the top, stop sharing and share it again because it's a little bit pixelated. And I would rather, people could see it properly. Okay, so this is a question for you guys. This is a question for on the street. And now share it again, please. For the people on the audience, please, have you considered using bifacial PV panels in your projects? Is it yes or is it no? Just please vote for me. Just tell me whether it's a yes or it's a no. Have you considered using PV panels in your projects? Right. Have we got enough answers? Araceli, can you share? Okay, let's hope in the meanwhile that... Okay, so most people have considered using PV panels, 72%. You can stop now that, Araceli, please. Thank you very much. Let's see now if we can see it a little bit better. Can you open that for us?
It is okay now. I'm sorry, maybe it is the connection of the hotel. But I will try to
never mind. Let's just keep going. In any case, just
quite clear and
just reminding people we'll give you the PDF anyway, so you can actually check it. Keep going. Sorry, Antonio.
Okay, thanks a lot. So I was introducing bifacial, this is the technical concept. Particularly, we are bifacial combined effect technology, and we are using the backside as active part. Not all with, so instead to use the real aluminum contact, we have the active surface with the grid silver tinting. Practically, we are going to use the PEC technology in both the sides of the cell. The module is laminated by two centered glass and encapsulated by two layers of PVA. Practically, our modules are dual glass modules. Using the bifacial, we are able to gain more energy because we are using the direct sunlight from the front side and even the diffuse light that comes from behind. Compared to the standard monofacial modules, if optimized during the design, bifacial module is able to generate from 20 to 25% more energy than conventional monofacial models. Of course, we need to define some parameters and we need to give some tips and topics about the bifacial, how to use them. So take into account that the bifacial guide definition is the difference of production in terms of the percentage between bifacial modules and the monofacial modules that is installed in the same site, the same configuration, and during the same period. This gain is affected by several factors, several parameters. The main important things, of course, is the albedo. Then, of course, there are the local solar radiation climate condition, the height for the ground level, the rear shading optimization. So this means that the multi-structure tracking must be designed and optimized, and of course the distance between the rooms to each other. Let's speak about the albedo. Of course, the albedo is the main factor, the factor that is able to increase the production at a parity condition. And according to the albedo of the ground surface, we are able to have additional gain of the production. So from water to wet plant, you have a table that, of course, introduce the gain that is able to achieve. This has been done in our internal test R&D department. It was, of course, done with some certain parameters, some tilt angle, some height, and the ground albedo was measured in a certain way. As you can see, the albedo is very important, but also the nature of the surface is also important, because if you see sand, for example, it's quite the effect to be more diffuse light, even if the albedo is less. That's the reason why all the simulation and design must be done according to the PV system design, because the albedo is one of the more important parameters, but even other parameters are quite fundamental. This is some other tests that we have done in our laboratory. We compared some different technology, polysets, N-type bifacial mono, N-type bifacial mono on white paint or white paint and on cement floor, and the P-type bifacial mono on the same condition. If you can see, optimizing the design and the height, we have been able to gain up to 27.5%. I have introduced some other parameters that can affect the facial gain. Tomorrow there will be another interesting webinar, and maybe the mounting tracking system supplier can explain you a little bit more in depth. I don't want to introduce some concepts that will be done by tomorrow. But as I told you before, the height of the ground level is very important, because the more is the height, of course, still at a distance, the more is the gain of we are able to achieve. And the same is for the pitch. The more is the pitch, the more is the reflecting area, and the more is the percentage of the gain that we are able to achieve. It is very important also to optimize the rear shading. This means the choice of the mounting structures and the design. We need to minimize all the shading that comes from the back. We are not, it is a new, different way to consider the design. Before, up to now, we will only focus on the front side. Now we need to focus also on the back side. So not all the mounting structure, not all our design as we intended the design up to now could fit the bifacial technology. Of course, we can give any suggestion how to simulate the bifacial in the PV system. We can offer the PowerPoint file and some tricks in order to do the design. And I would like to summarize some conclusion, some pro and cons about the bifacial and versus monofacial. Of course, monofacial can use only the front side. Bifacial is able also to use the back side. So the radiance that come from the back side of the models. This will increase the power that the models is able to offer. Of course, in terms of glass power, this is a glass-glass solution. So even if we are going to use the same technology of the pixel or that normally we use for standard monofacial models, the glass power will be a little bit less, depending on because of the glass lamination. But in any case, we are able to achieve up to 25% more, depending on the ground reflectivity and of course depending on the design solution. Unfortunately, bifacial, as there were not any international standard that release the total power between the front and the back. There are some concepts, there are some guidelines that I guess will become really soon effective, but at the moment, the data sheet of the modules are not yet uniform. So you will find a lot of data that is very difficult to compare. The bifacial modules has also an added value that is quite aesthetic, because being a glass is a very, this is another value. It is designed for system on 1500 volt, so this means less spring, so faster installation. Our modules, our bifacial modules could be offered frameless or with frame. The performance warranty, of course, is better because it's due to the technology. It is anti-PIV, and of course, being dual glass, it's more resistant in harsh conditions. So less microcracks, less snake problems, less corrosion, because the glass and the harsh are the resistance to a harsh environment. So hopefully I've been in the time that you gave to me. It was just a brief introduction about the bifacial. I'm here, to answer for any question you may have. Here you can see my email. Sorry, this is a mistake. It's antonio.ruta, antonio.uta@5solar.com. And I'm here available for any question you may have.
Thank you very much, Antonio. We did have a few issues with your presentation. It looked pixelated, so I would ask you, can you email it to me now and Araceli so that we can send it to the people right away and they can see it? I would really appreciate that. I'm sorry we had technical issues. Sometimes we're not even sure why it happened that it pixelated. We'll go to the other presentation by Juan Carlos now, and then we will ask, I know that there's a bunch of questions, most about cost and how does it work, how does it compare. We will get to those after the other presentation. Juan Carlos, could you share your screen, but make sure that you open the document and then you choose the document rather than the desktop, because I think that might have been part of the problem. See, there is even questions, Antonio, about albedo measurement. We'll get to you on that as well. All right. So I just wanted to also have Antonio's email, because I know if you want to reach out to him, then you can, it's jinko.com, correct? Yep, I just sent it. Perfect, thank you very much, Juan Carlos. Just make it large for me, please. Because at the moment we cannot see the deck.
Yeah. I shared already.
So this one, we're seeing perfectly, so it's good. It's no longer pixelated. Let's go for it.
Okay, thanks, Belen. Thanks to all of the attending people here to this afternoon. I would like to first maybe to introduce a bit about Longi, because maybe many people they have learned something in press releases or in magazines. I would like also to introduce a bit monoperk, especially, I mean, regardless if it is monofacial or bifacial, because at the end, this is the key question for having this opportunity or this technology regarding bifacial. And yeah, I will show also some gain or some comparisons in between monofacial perk and poly, just to show the difference between both technologies. This will be for sure applicable to bifacial technology. So on the front side, so we'll have a gain first on the front side. We'll see that this is around 3% compared with polycrystalline technology, and then from the rear side, depending on our design. Okay. And after that, I will also introduce some specific parameters to be considered on the design of bifacial installations. Okay, just for your reference. Okay, so let's start. So first of all, Longi was founded in 2000. At the beginning, Longi was just doing, let's say, ingots or silicon related to electronics, not to PV. They changed a bit, still doing something regarding the electronics, but silicon for electronics, but they changed completely a bit the focus to solar. We started in 2007 in September with a facility of 1,000 tons of ingot, monocrystalline always. Let's say, or let's have this clear. I mean, Longi just produced monocrystalline technology on the whole chain, but only monocrystalline technology, poly. Okay, somehow Longi has been or is the one. Okay, in fact, Longi established a wafer facility of 350 megawatts. 2012, we were listed in the stock exchange in Shanghai. We became the largest mono wafer supplier globally, worldwide, in 2013, delivering 1 gigawatt of mono wafers. And in 2014, we acquired Lerry Solar. Lerry Solar started in 2007 doing, manufacturing panels. and we just acquired Larry Solar at that time in 2014, and then we are finally we are vertically integrated from the ingot to the panel. Okay, it is last year in 2017 produced around 15 gigawatts of ingots and wafers and around 6.5 gigawatts of modules. Okay, let's say our aim is to produce double capacity on wafers compared with modules. Three different of them is, we'll see later, I will explain it later maybe. This year, 2018, our capacity on wafers will be around 25 gigawatts and on modules in between 10 and 12 gigawatts. 2019, wafers will be on 35 gigawatts to be at the end in 2020 around 45 gigawatts on wafers. Okay. As I said before, Longi has three main units. One unit is Longi Silicon. We just produce mono ingots and wafers. This unit is also able to sell directly wafers to the market. We will talk today mainly about Longi Solar, where we produce mono cells and mono modules. Okay, and finally we have another branch which is Longi Energy. For the moment, just located or focused in China or Asia, acting as an APP. Okay. Our main product, even if this till end of this year, we are also producing a mono standard panels or mono standard cells. Our aim is to shift all the capacity, all the production to mono PERC, and this will be our main products. Only three. Okay, in principle, we will have another one in the future, but I don't think it's now the moment to mention it. We have the mono PERC and monofacial, which is the IMO one. We have bifacial mono PERC with a standard cell, size 6-inch cells, which is the IMO 2, and the IMO 3 is the half-carried bifacial PERC. Okay, so this is also based in mono PERC technology, but with half-carried cells, with all the advantages of this technology. Maybe this will be a product to be discussed in a separate webinar. Okay, because all the advantages that half-carried cells can bring to the design and to the energy produced. Okay. I would like just to, as I said at the beginning, I would like just to make a comparison in between mono PERC technology and poly, just for you to see the advantages of the mono PERC technology. Here we have two sites in China, one in south of China, hot and humid climate, another one in the north and hot and dry climate. In both cases, there is a comparison in between our two sites, comparing mono PERC and poly technology, and we can see in both. I mean, as an average, we are over 3% higher production compared with multi technology. Okay, if we focus in one of them, in the one on the left, in Saya, here is the reason why. Okay, we can understand what are the factors bringing or improving or boosting the produced PERC with the poly technology. First of them, we can see on the left side on top the graphic on the behavior of both technologies regarding the irradiance. So we can see that mono PERC technology is able to produce more energy with low irradiance conditions, which is somehow most part of the time during the day, especially during the morning and later during the evening. Okay, so we can see we can harvest more energy from our installation by using mono PERC technology, regardless if it is monofacial or bifacial. Okay. Another key parameter is the temperature. So as you know, both irradiance and temperature are the key factors for the solar or the PV technology to bring the energy produced up, okay, or down, depending on the characteristics of the panel and the conditions. So we can see here on the right side another comparison regarding the temperature, the behavior of both technologies. We can see that as an average, poly technology has 3 degrees Celsius more compared with the mono PERC technology. at the end is impacting directly the energy produced or the power that we can get in a specific moment from our panels. So these two characteristics bring us to the third graphic on the bottom side on the right. This is the behavior of the inverter. So with mono-PERC technology, what we can achieve is to have the inverter working more hours, since the mono-PERC technology is able to produce more current during the morning. The inverter will start earlier, and will happen the same during the evening. Okay, where we will have lower irradiance, since the technology is able to produce more current. Then we will have the panel producing, or the inverter connected more time during the day, along the day. Okay. Regarding bifacial technology, we have two options: the high mode 2 and high mode 3. Okay, one based, as I said before, one based in a 6 inches cell, and the other one in half-cut cells, also based on these 6 inches cells. Okay, and right now, as of today, from our facilities, we can offer two different options in 60 and 72 cells. In 72 cells, we are reaching on the front side around in between 360 and 365 watts. In 60 cells layout, we are able to get in the market in between 300 and 305 watts. Okay, with a power ratio or a bifaciality of 75%. This means that under STC conditions, the panel on the rear side will offer 75% of the front side. Okay, and then the rear contribution, depending on the irradiance reaching the rear side, will be, we can see it here in the bottom side. Depending if it is, let's say, 10% for a 360 watts, we are able to get, to get from for one single panel 396 watts. Okay. We will see later at the end what does it mean in terms of design and an approach to our CapEx and LCO. Okay. And on the right side, we have the power distribution right now for the standard, for the IMO 2. So the standard cell, we are able to produce 360 watts mainly and 365 watts. If we the technology from standard cells to half-cutted cells, this will be increasing 5 watts. Okay, so we are able to produce in between 365 and 370 watts for half-cutted cells bifacial on the front side. Yeah. Our product is based initially in a framed option. We are for sure also able to produce and to offer to the market a frameless one, but we see that with the frame design, we can reduce. There are many benefits. First, on the handling of the panel during construction, we can reduce the impact on the breakage. Second, on the cost of the mounting system, since we can use standard screws or clamps, compared with a frameless situation where we just can use somehow clamps, more expensive in terms of cost itself for the product itself, and also during construction it takes more time to install the panels with clamps than with screws or with omegas, for instance. Okay, and also in an indirect mode, this frame allows to reduce the ingress of moisture, so we can also get a better behavior on the degradation basis, okay, compared with a frameless one. Okay, and what else from this? For sure, this situation, since we are using glass topology, the panel is made, is certified up to 1500 volts. Okay, even if it can be used also with 1000 volts. Another characteristic is that we are changing our the lamination. The components, the internal ones, EVA from EVA to POE. So we are changing from EVA to a polyethylene, another polymer, which has better behavior than, or stability than EVA, has a higher dielectric, so can avoid better the PID in case if it appears, okay? And also low moisture transmission rate, which means we can also improve the degradation or reduce the degradation of the panel, okay? In case at the end, the moisture is one of the key parameters to reduce the power or to influence the degradation of the panel. Okay. Another maybe key point from our product compared with the one you can see in the market is our warranty. For the first year, being mono-PERC is 2%. We know that for poly technology, the degradation is 2.5% for the first year, and standard mono and mono-PERC in the market is offering 3% for the first year. So we are improving 1% for compared with the mono technology in the market, or 0.5% for the first year. And the degradation from the second year to the 30th year is 0.45, which is 0.05% below the standard in the market for a dual glass or double glass layout or lamination. Okay, so at the end, comparing with a standard panel, we are offering a power availability in the panel of almost 5%, compared with what you can find in the market right now, which somehow enables to improve the LCOE for sure, and the energy yield along the time. Let's talk a bit about a small summary about the design with bifacial modules. In our case, with mono-PERC bifacial modules. Okay. What are the key parameters to take into account? This is normally shown in PVCs. We can see also that there are more parameters in PVCs that are not here shown, but main parameters are still for sure the clearance. This is very important. We will see later why. Also the space, the pitch or space in between rows, or the ground coverage ratio. Okay, we will see later one by one. And albedo, or the reflection for sure. This is maybe the most important one. But all of them are related, so you can play with all of them just to bring to make the design of the panel, the installation. At the end, the design of an installation with bifacial panels has nothing to do with a standard panel or what we did till now. So we need to take care a lot of all these parameters to make sure that we get the gain we are expecting, and we are not failing in our design. Okay. So one of them, as I said, is about the albedo. Somehow this is also related to the ground coverage ratio or the power density or the pitch. So the higher power density, the closer are the rows. So smaller is the pitch. So by distance between rows, we can for sure increase the gain at the end. But for sure, at the end, we need to have a compromise in between this distance and also the cost, since if we have longer, we'll have longer trenches, longer cables, and more workmanship there on the construction. So we need to look for the equilibrium or the balance in between cost and benefit on the distance between rows. Okay. Also the albedo, it will depend. Also, it is very important maybe the operation and maintenance, because maybe we are considering let's say a dry land, but along the time we don't consider the operation and maintenance, and then we start to have some grass or vegetation around, not uniform, or maybe not homogeneous. So at the end, we are acting the mismatches on the rear side of our installation. Okay. Another parameter is the clearance from the ground to the panel. So we can see here on the left side this graphic is showing the relation in between the bifacial gain and the clearance from the ground to the panel. Okay. So there is a moment where we reach the maximum gain, and regardless if we want to increase the clearance from the ground, we are keeping the same value. So this is also important in terms of cost. We don't need to go that up or to have a bigger clearance than needed, Otherwise, we will have a higher cost on our mounting system. Okay, so we need to look for the key, or for the, let's say, the minimum clearance we need to get the maximum benefit. Okay.
So Juan Carlos, we have very little time. So
Yeah, I'm finishing. This is the next one is about the mismatching on the rear side. This is representing an array on our installation. So the panels on the perimeter or on the edge of the array are can see more light because they don't have neighbors as stopping the light. So we have somehow, and the ones in the middle will see, let's say, less irradiance because they have neighbors that are somehow impacting the irradiance around. So at the end, we will have a mismatch. We need to take this into consideration, especially from an electrical connection point of view, to reduce at maximum the losses. Okay. And finally, regarding the sizing of the components, we need to take into account the sizing, considering the inverted clipping or the rating. I mean, let's say if we consider an albedo or a gain on the rear side, and this gain on a real situation is higher, we can get the inverter working let's say, overload, and the inverter for sure will protect itself just to cut the power coming from the array. Okay. And finally, we can have two approaches. I said this at the beginning. We can say, okay, let's, knowing the gain on the rear side, we can reduce the expected energy yield if we compare it with a monofacial installation, or we can keep the same, let's say, the same number of panels design to increase the energy produced compared with more, or in dollars per kilowatt hour, or euros per kilowatt hour, instead of dollars or euros per watt peak. Okay, this will be related mainly to the. Thanks for your time. Here below you have this is my name, my email, if you have any other additional question later, and also my telephone number. Okay, thanks, Belen, and sorry for the time.
Thank you, Juan Carlos. I can't see your email in there, but if you just put it in the chat box so everybody has it, because somehow I don't see it in that slide. And if you can stop sharing, please. We have a few minutes for questions and answers, so we're going to launch into them. Whereas we give Juan Carlos a chance to, stop sharing and take maybe a couple of minutes. Antonio, there is a couple of questions you want to answer live, correct? You've marked one here. When are your modules available for utility scale power plants? What are the present manufacturing capabilities? Do you want to answer that?
Hopefully you got my voice. Hopefully.
No, we have can you switch off
Yes.
Yeah, now it's better. Perfect. Go for it. Answer.
Sorry for this. So I would like to answer to some questions. The first question is about the capacity.
The speakers on your computer, because they're repeating the voice, so we're not hearing it once, we're hearing it many times. Maybe
1 second.
Sure. So. Can you stop sharing, Juan Carlos?
Hopefully it's okay now.
Yes, it's okay now. Go for it.
So, the question was about the capacity and when the model will be available. We are going to switch to the mass production during this Q4.
That's okay, right?
Okay, do you hear me?
Yes, I can hear you. We heard someone else, but we can hear you. Go for it.
Okay.
Keep going.
Okay, sorry for this product. Sorry for this problem. Hopefully tomorrow will be better. So about the capacity and the production, we will have more or less 1.5 gigawatt capacity for next year for Bifacial, and this also will include the new development that we are going to do. Of course, my presentation was quite tight in order to be in the 10 minutes, so I have not going through all the methods that I guess Juan Carlos has done in a very good way. But the technology is the same, so we are more or less on the same level. Apart some choice about the technology and which material to use. But as I told you, we have more than 230 BOM combination, and we are able also to offer different BOM solution applied to the bifacial. What I can say that the production we started during during this Q4, we are going to have 1.4 gigawatt production. There was another question, sorry, that I've highlighted before to all my problems. And about price, yes, about price, I'm not the right person because I'm the technical service manager. So I would be happy to forward all your requests to my colleagues that are all around the world. Of course, there are some price gaps that are, that will be, it will be, of course, on the other side, have the advantage that we have introduced today. So the COE in any case will be lower, and so we have a better IIR thanks to this solution. But there are some different tips, some different add-on solution that we can use. So the bifacial could have a range of prices that could be differentiated between one solution to the others. What I may say that we are also introducing soon bifacial with a larger cell, not anymore cell with the 6-inch cell, but a little bit larger, 6.25 to be precise. And this will help us to increase the power density of the modules and to offer high power thrust. So this is really a new product that is going to be developed in a very fast way. It is really the future of PV. Of course, this must properly designed, as it was introduced by me and also by Juan Carlos, and you have to use some special tips and special suggestions.
So,
sorry, just another question. The modules will be certified according to the current certification. When the new IC and the new standards will be released, will be, of course, follow the standard and will certify the modules according to the new standards. Okay.
So you have answered a few questions, but I have one of my own that I was hoping that you could answer. The two of you, actually. One is, let's say today, if you take bifacial, is say 0%, maybe it's 1%, I don't know, but let's say 0% of everything installed, and bifacial is 0%, and normal traditional PV is 100%. What do you think this distribution is going to be like by 2020? Today, like sort of 2 years from now, what are we going to see in terms of on the ground, this percentage? Just so that I have an idea, you say that this is happening fast, but how fast? In 2 years, are we going to go?
I can say from our point of view, I mean, from Jinko point of view, that the capacity will be next year at around 10 to 50% of our total capacity for the bifacial. And I guess maybe we will increase the year later. I'm not sure about how much. This is also depending how will be the next development of the technology. So if we were going to follow the road that we are at now, or do we straight to other solution that will increase the power density? It is very is a process really dynamic. All photovoltaic is really dynamic. So we need to, at the moment I can say that maybe will be double, but this is information will be available maybe next year, starting of Q1 2019.
Okay, so what about you, Juan Carlos? How do you see this developing for 2020?
Well, in our case, I mean, as you can see in our portfolio, we are mainly focused, I mean, for sure in monoPERC, but also our key product will be and is bifacial in all the layouts. Let's say with standard cell, half-cutted cell, and also shingle. We will see this later, maybe next year. And if I consider that our capacity for bifacial could be around 15–20% of our all capacity. I would take that regardless the technology, maybe will be monoPERC, P10 type, another. I mean, different technologies, but at the end, all them based on bifacial. Once the people realize or the market realize that the LCOE is improved by this technology or this of product, and also CapEx can be reduced. I mean, this will be, I understand, a common product in the market. Okay, so could be easily 20%, I expect.
I hope so. I hope so. Okay, so I'm going to go through some of the questions, but before I just want to remind everybody that questions of cost, you love to ask them. I love to ask them myself, but yeah, I never really get a straight answer, do I? No, you don't, because this is a petit comité sort of thing. So you've got Antonio's email, you've got Juan Carlos's email. If you've got some answers, some real answers, write to them. They will actually move it around their team and actually give you some proper answers. I think you do have to consider this new technology. This is the future. Question is how much it costs. They're convinced here that it's worth your while to look at this. Just get in touch with them. I think that's the way forward. Let me go through some of those questions. First is, in PVCs, what is the realistic value of mismatch loss to be considered? Do you recommend this value to be different from 1,500 volts and 1,000 volts DC system? Who wants to take this question? Antonio? I can't hear you. You have to switch on your mic.
Well, in my, as I showed in my presentation, mismatching the real.
Juan Carlos,
no, okay. If Juan Carlos wants to answer, I will answer later. Sorry.
Okay, go on, Juan Carlos. We can't see you at the moment, so that's why I wasn't sure you were answering.
I don't know why. I don't know. No, I can't.
It's fine. It's fine. Let's just keep going.
Okay.
Go.
Well, as I said, as I showed in my presentation, mismatching on the rear side can be, at the end will be a matter of irradiance, and it depends mainly on the design of the installation. For sure, if we have comparing 1,000 volts with 500 volts, since depending on the design, if we put the panels along a row in the tracker or in the mounting system, we can maybe expect more mismatching on the same string. So as I said also in my presentation, the electrical connection can be, is key maybe to reduce that. The maintenance of the ground is also key to reduce the mismatching. And maybe an option is to, I don't know, I didn't check that, but maybe an option is to take into consideration the current on the rear side. How sorting by current, maybe we can install panels in the same string with different level of current that can reduce this mismatching due to the difference irradiance. Also, it's important that the design of the panel, there is a parameter in PVCs related to the transparency of the panel. So this is also a key parameter, maybe to bring a more homogeneous irradiance for each panel. Okay, just going through the glass. Okay, and also the design of the tracker. There are specific trackers for that purpose, for this technology, that are somehow allowing the light going in between panels when we are talking in a 2V installation. So I remember now one of them from Spain. I will not say the name, but very well known. That they allow to the light to go in between, So there are many parameters here.
Just to let you know, guys, we don't have a lot of time, so keep your answers shorter so that we can get through more questions. Antonio, your turn. Just take the mute off, please, so that we can hear you.
Yes. Okay. It was introduced before. The question is the length of the string and all the other parameters that is affecting the production. I may say that being bifacial, the rear part can produce from 10 to 50% more gain. So the class sorting, of course, could help to minimize, but there are the other parameters that are really important. One of the parameters is also where the module is located. So the string and the group of strings that is related to the same junction box. So you see, it's there are a lot of parameters that must be considered. And so only if you have more or less the idea of the design, what will be the effective phase, what will be the solution in terms of the mounting system, breaking or not breaking, and the connection of the cable and the modules, maybe we can have a clear idea how to suggest to minimize the selection loss. Okay.
Thank you very much. There is a question here about soiling losses that I'd like to ask you. I'm trying to keep the questions to the panels themselves because tomorrow, you know, we're talking about the plant design. So I'm trying to avoid those. Yeah, tomorrow we're going to have a chance to learn more about this. Says, what is the standard soiling losses for a plant with bifacial modules? I assume the rear is a little bit, you know, easier to. Does any of you have any answer for that? Antonio?
I would say it depends on the site, right? Actually, and I understand also depends on the climate. If this is a lot of humidity, maybe the soiling will stick on the surface. If there is not, maybe will be easy to be removed somehow by self-removed by the wind and the gravity. So it depends. I understand on this humidity and the location.
What about the topics of regulation? Is there anything? I know that in the US, you know, it's an area in which bifacials have been embraced because regulatory in terms of tax, they were advantageous. But what about other places in the world, like Europe? Is there anything people have to be aware of? There has been a question about this, and I think it's an important one. Who wants to, Antonio, go for it.
Yes. Okay, sorry. In terms of regulation, as I told you, there is not the moment official standard how to identify the bifacial models. So at the moment we are using the existing regulation, the IEC that we have. There is a draft of the new regulation in order to consider the same panel on the same level. This is in terms of certification. In terms of regulation, this is a standard PV models. So you have to follow the local regulation in terms of installation. So if you are in Italy, you have to follow the other rules. If you are in another country, like another continent, they have other different rules. We are going to issue, of course, a few instruction or EU instruction according to the environment that the model will be installed. Okay.
Next question. Let me just move really quickly. Can energy yield be in bifacial modules be checked by a third-party simulation software? I suppose other than PVCs. Is there any other such softwares available?
I think there is one available from I don't know if it's NREL or something similar, but I don't think it's for mass. I mean, for utility scale. It's more about the behavior of the panel, the bifacial panel. They are using a different approach compared with PVCs, more related to the light. I mean, to how to play with the light and so on. But I'm not pretty sure about that, to be honest. I mean, the most used one is PVCs, and the one that banks are taking into account. So.
My understanding is that PVCs is evolving anyway, but even like that, you know, it would be good, I suppose, to have one to check. Antonio, do you want to add anything? I wasn't sure.
No, I confirm what Juan Carlos told. PVC is the most used software by legacy company. So normally we relate with this information, and we are going to provide all the information about font that can be used with this software.
Okay, just one more question and then we'll leave it for today. With frame versus frameless. Probably a bit of a technical, here people are like, you know, what are best? Are these ones best or are those best? Do you guys want to give your explanation? I don't know who of you want to start.
I will start by myself because Jinko, I guess, is the only one that is offered frameless and with frame. It is, of course, depending on the design and the final choice of our customer. What I may say is that, of course, frame is a different cost compared to frameless. But on the other side, there are some difficulties how to fit frameless models in the 16-month structure, especially when we are going to use tracking and not the standard fixed month structure. At the end of the day, it's a question of LCOE. So the FEC, the designer that is going to, to provide the right design of the models, is the right, person that, or the right subject that is to go or to run for the simulation and to understand if the frame or frameless, what is the best choice for him. We are looking how to, to help the APC or the installer with this kind of topic, but this is will be development that will be online, I guess, next year.
Thank
Okay.
you. Same question to you, Juan Carlos, if you want to add something, and then that will be it. Although there is another one here that I'd like to squeeze.
Yeah, I mean, regarding this question, for sure, we are also able to provide both options, frame and frameless ones. Particularly, we still think that frame one is much better compared with frameless one, since, I mean, all the advantages I mentioned before. As I said, if someone wants also a frameless one, we are able to do it. Only thing is about, you have to take care about the torque applied to the clamps. You can have loosening along the time, and then the panel can slip down, or if you apply too much torque, then you can, there are many. We bid for frame one.
Okay, well, thank you very much. You've heard from two leading manufacturers that are looking at this technology. This technology is the future. I think this is what's clear. I think we might, quarrel about the little details, but we know that the forward and everyone is betting really strongly in bifacial. We are tomorrow looking at the project itself. So what do you have to look at? And we will go into a lot more detail. There's been a few questions about albedo. There's been a few questions about design, about tilted versus, like with tracker. All of that stuff we'll look at tomorrow. Thank you very much for being here today, and we expect you tomorrow as well. Thank you very much, Antonio. Thank you very much, Juan Carlos. Really appreciated you being here and shedding some light.
Thank you.
This is the beginning of the road. Yes, and I will see you tomorrow, actually, Antonio. Thank you very much. Speak soon. Bye.